Hey guys, welcome to Unit 4. So Unit 4 is going to take all the stuff that we've learned in the last few units, and we're really going to dive deep when it comes to anything and everything linear. Linear functions, linear equations, and linear inequalities. So to begin, we're going to look at arithmetic, or I've also heard it pronounced arithmetic sequences. So arithmetic sequences, those are sequences or patterns that have, well, they're linear in patterns. So let's start off with looking at this truss design. So a truss design like train tracks. So there's a pattern in this truss design. So if we look, it says, how do the number of beams relate to the number of sections? So if we look, our first section has 1, 2, 3 beams. And then our next section, so 2 sections, ends up having 1, 2, 3, 4, 5, 6, 7. So it has 7 sections. Sorry, 7 beams. So the next one, so 3 sections of truss, see those are 3 sections, actually has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 beams to build the 3 sections. Okay, so how does the number of beams relate to the number of sections? Well, let's look for the pattern. Each time we add a new section, how many more beams are we adding? Well, 3 plus 4 gives us 7. 7 plus 4 gives us 11. So how does the number of beams relate to the number of sections? Each time we're adding a section, we have 4 more beams. So how many beams would be needed for 5 sections? Well, if we continue this pattern, so 4 sections, I'm going to add 4 more beams. So I end up with 15 total beams. So 5 sections, when I add 4 again, I'll end up with 19 beams. So 5 sections has 19 beams. Now I want you to think about, can you come up with a shortcut for how to figure out how many beams there would be in 10 sections without having to add 4 every time? See if you can figure that out. All right, so I'm wanting to skip all the way to 10. So I see that I'm adding 4, adding 4, adding 4, adding 4. Okay, so I'm going to add 4 5 more times. So I'm going to add 20 so that I end up with 39. So if I'm adding 4 5 more times, so I'm going to end up adding 20, I'm saying that I have 39 beams in 10 sections. We're going to come back and check my work because I want to see, does that actually work? So for any arithmetic or arithmetic sequence, okay, there are a couple formulas that we can use to figure out how many of whatever. So in the first example, how many beams there are in as many sections as we need. So if we're actually building a train and we know that we're going to have 75 sections, well, I don't want to have to continue doing plus 4, plus 4, plus 4. I want to figure out a way to where I can go right from the beginning and say, okay, each time I'm adding 4 more, boom, this is how many beams we'll need for 75 sections. So we're given explicit and recursive rules to do these functions, okay? So when we're looking at patterns of numbers, if they are linear in trend, so if they're linear, also arithmetic, they are either adding or subtracting the same thing every time. So if we want to find any number in this sequence, so if I want to find the 12th number or the 75th number or the 128th number, I want a way to do that without continuing my pattern. To do that, we're going to use the explicit rule. The explicit rule, it allows you to find any term Allows, how about helps? It helps us to find any term. In a sequence. Really in an arithmetic sequence. Let's add that. In an arithmetic sequence. Just a fancy way of saying linear. So to use the explicit rule, it starts off with a sub n. This is just a way to denote the nth term. So whatever term you're trying to find, again, 25th, 50th, 100th, that's what would go there. So a1, that is our, so if an is the nth term, a1 would be the first term. So whatever our sequence starts with, then it says plus d. D is our common difference. It is what we are adding or subtracting to the sequence every time. So again, n is just the nth term. Whether we want to find the 49th or the 76th, however we want to do it. So let's look at these two patterns. So I have 3, 15, 27, 39, 51. What is my pattern? So from 3 to 15, I add 12. Let's see if that keeps working. 15 to 27. I also add 12. 27 to 39. Perfect. Let's make sure it works for the last one. Yep. Add 12. So our common difference is 12. So when we go to set up an explicit rule, I've got a sub, well, which term do we want to find? So it says, given the following sequences, use an explicit rule to find the, I'm just picking a number out of the hat. I'm going to say the 37th term. I know, I'm being random. That's fine. So a sub 37. So the 37th term is what we want to find. So again, what do we begin with? Our first term. So the first term of the sequence is 3. And then what are we doing? What's the pattern? So to that 3, what are we applying? We're applying a plus 12. Not 2, 12, sorry. And now is where we find out how many times are we adding 12? Well, to the 37th. So I do 37. Now notice how it says 37 minus 1, or n minus 1. Why am I subtracting 1? If I'm trying to find this 37th term, wouldn't I want to multiply it by all 37? Because I'm adding 12 that many times? Well, think about it. We're actually not adding 12 37 times because the first term is where we started. So since we started at 3, we're only going to add 36 more times to get to the 37th term. So you always have to subtract 1 to make sure that you don't end up accidentally counting that first term again. Okay? So let's find out, well, what would the 37th term be? So I'm just going to 37 plus 12 times 36. Once you get comfortable with this, yes, you don't have to write down every single step. That's fine. So I'm going to simplify. 3 plus 12 times 36 gives me 432. So the 37th term of this sequence is 435. Now, wasn't that so much easier than continuing that pattern and doing 51 plus 12 plus 12 plus 12 until we got to the 37th term? Oh, that would have been obnoxious. So explicit rules help us to simplify super fast. All right, let's try that one more time. 8, 3, -2, -7, -12. Okay, so I'm getting smaller. So from 8 to 3, I subtract 5. 3 to -2. Yep, I subtract 5. Subtract 5. Subtract 5. Beautiful. Our common difference is -5. So notice we have a negative common difference this time. So let's go ahead. We'll just keep doing the same thing. So if we go to find the 37th term, so where did we begin? What was our A1? So our A1 this time is 8. And what are we doing? What is our pattern? We are subtracting 5 and times n minus 1. So again, we're finding the 37th term. So 37 minus 1. If you just wanted to write 36 in there, that's fine with me. These are your notes. All right, so 37 minus 1. So I'm going to simplify. I've got 36. So 8 minus 5. And I just need to simplify. So -5 times 36 gives me 180. So 8 minus 180 is going to leave us with -172. So our 37th term in this sequence is -172. Okay, so explicit rules, again, what do? They help us to find any terms of an arithmetic sequence. Okay, let's go ahead and bubble that in. Beautiful. So I have this other thing up here, this pesky little recursive rule. Now, recursive rules are not crazy useful. However, I'm going to show it to you because I'm supposed to. Recursive rules allow you to find the next term. Okay, so super helpful, right? I've got a common difference of 3, and my 15th term is 75. What's my next term? 75 plus 3, 78. Essentially, that's what the recursive rule does. It says a sub n minus 1. Well, a sub n is the nth term, so if we go 1 before it, that means the term before. And then we just are going to apply our pattern and add the common difference. Or subtract, excuse me, or subtract if it's negative. Now, why I bring this up? Because on your end of course exam, there is a potential where you might see in a select all that apply a recursive rule, which literally will just plug in. So a sub n minus 1, it will be written like that, and you'll just replace your pattern with your common difference. That's literally the only thing. So your recursive rule will look just like this, except for the first example where we added 12, it'll be a sub n minus 1 plus 12. And the recursive rule for the second example where we subtracted 5, a sub n minus 1 minus 5. That's literally it. That's all I need you to do. Again, recursive rules not super helpful unless they're already saying, hey, the 99th term is 10 and our common difference is -2. So what's the 100th term? Well, I'm going to subtract 2 and boom, there's my 100th term. So again, not super useful, but we do need to make ourselves familiar with it in case we see it in a testing situation. All right. So let's give a little real world application to this. How much money will Logan have on the 18th day? All right, well, we should probably read about what Logan's doing first. So, Logan, saving money in his piggy bank for his upcoming trip to Disney World. Awesome. On the first day, he put in $12 and plans to add $7 more each day. Okay, what's key? So first day, we start off with $12. Awesome sauce. Then what? Plans to add $7 more each day. Perfect. So write an explicit formula that can be used to find the amount of money saved on any given day. All right, so I've got A sub n, because any given day, so I don't know what day, they didn't tell me yet. So A sub n equals, all right, so our first day, 112. So we start, sorry, not 112, 12. So he starts off with $12 in the piggy bank. What's he doing? Adding 7, so plus 7. And what do we have to multiply it by every time? N minus 1. Whatever term we want to find, minus 1, because we have to take into account we didn't start at 0. We're starting at a different point, in this case with the $12. So there's our explicit formula. So let's come back. It says, how much money will Logan have on the 18th day? Okay, so on the 18th day, so I'm going to replace all of my n's with 18. And then let's simplify. So on the 18th day, it's got $12, and then we're adding 7 more. Times 17, not 18. So 7 times 17 gives us 12 plus 119. So on the 18th day, Logan has 19, 20, 131. Awesome. That's pretty good. 18 days and you already have over $100. All right. I mean, I don't know where he's getting the $7 from to add, but that's pretty cool. So it says the Disney trip is in 187 days from the day he started saving. So how much money will he have on the 187th day? I'd like for you to go ahead and pause the video and find out how much that he'll have on that 187th day. And when you're ready, come back and check your answer. All right, so I'm going to go ahead and drop the 1. So I'm 186 times that I'm adding the 7. So let me get my handy dandy calculator for this one. 12 plus 1302. So after 187 days, apparently Logan is taking an awesome vacation at Disney World with $1,314. So apparently he's not only buying everyone's ticket, he's also probably staying the night in a hotel or something. So he's gonna have an awesome Disney vacay. Cool? So let's retrace. So explicit rules, they help us to find any term of the sequence. Recursive rules only help us to find the next term. So not something that we will use often, however, we do want to make ourselves familiar with these two formats. All right, give your homework a try. Let's see how you do.